I will not be able to understand whether you are with me or not. So before starting the session, as customary, I start with a prayer. So let me start with a prayer, and then we will understand the schedule of today's lecture. So let us start with a prayer. Om, lead us from unreality to reality. Lead us from darkness unto light. Lead us from death to immortality. Om, peace, peace, peace. So I think I'm audible. Can you hear me?
Yes, sir. Yes, sir.
Yes, sir.
So as you know, today's session, the session is visualization of data through SPSS. So can you tell me how many of you are ready with SPSS so that you can do along with me? I have already shared the data sets that I'm going to use today. So have you got all the data sets?
Yes, sir.
And are you ready to do along with me?
Yes, sir.
So how many of you can do along with me? Then I will actually adjust my speed so that you can do along with me. How many of you can do along with me? Just you can use the chat box. Just type yes. How many of you? At least 15 should do. So, okay, let us start with the program. I will be writing. If it is visible, just tell me. And due to internet issues, I will be switching off my camera because I will be using the screen. I will share the screen. So at any point of time, if you feel any problem, you just remind me. And if I go little fast, tell me to slow a little bit so that you can do along with me.
So keep the mobile open.
Yeah,
Okay.
mobile is open.
Okay,
Mobile
so
is
that if you're disconnected, then I will call you.
Yeah. No issue. Mobile is open. You can call me anytime. So let us start the session. I will be sharing the screen. Just tell me. You can unmute and talk with me if you like. At any point of time, if you feel that you have query, you can unmute and talk with me also.
Okay, sir.
Can you see my screen?
Yes, sir. It's visible.
Okay. So today, our topic will be visualization of data. Now, first of all, we need to understand how many types of data are there. Can anybody say how many types of data are there? How many types of data? Have you heard about measurement scale?
Yes, sir.
So how many type? Nominal,
Ordinal,
ordinal,
ratio,
interval,
ratio.
ratio scale. Since we will be using SPSS, SPSS call interval ratio as scale data. and nominal, ordinal, like nominal and ordinal. But we know that when we are talking about nominal and ordinal data, it is categorical data. And interval and ratio scale data is called continuous data, continuous scale data. So the categorical data is also called discrete. So this is, you already know, I think. This is clear or not?
Yes, sir.
Now, can you, so data is clear to us. Now we are talking about visualization. What is visualization? Generally, if you think of statistics and using statistical tool or softwares like SPSS or Jamovi or R or Python, today we will be focusing on SPSS because our program is on SPSS. So statistics basically to me, again, is of three types. One we call descriptive statistics. Other we call illustrative statistics. And the third one we call inferential statistics. So can anybody tell me something about descriptive, illustrative, and inferential?
Sir, descriptive state the mean, median, mode, describing the data. And I think illustrative is the pictorial, graphical representation.
Yes. And what is inferential?
Inferential means conclusion about the data.
Good attempt. Generally, first of all, we need to understand the data. Whenever we are doing research, we need to understand the data, whether primary data or secondary data. In order to understand the data, we have to apply this descriptive and illustrative statistics. Why? Because it gives direction that whether what is the summarization of our data, how we can approach for analysis. Analysis is taken care of by the inferential statistics, but basic understanding of the data is taken care of by descriptive and illustrative statistics. Descriptive statistics means, say, measure of central tendency like mean, median, mode, measures of dispersion, range. So these things actually help us to summarize the data. Illustrative statistics means graphs. Today we will be focusing on illustrative statistics because today's session is on illustrative statistics only, which we call as visualization of data. Why? Because you know, a popular adage says that a graph speaks 1000 words. So when you are speaking 1000 words, if you don't speak 1000 words, instead of you use a graph, it is synonymous. So graphs actually is a very understandable tool for layman. So graph is very essential. And when we have understood the data with the help of descriptive as well as illustrative statistics, that is graphs, we now try to find the validity of the data, or we now find to do the analysis with the help of inferential statistics. Inferential statistics helps us to draw inference about the data, whether the statistics that is revealed is significant or not. That's why we call p-value comes into the picture, and we do some lots of inferential statistics. So actually, descriptive and illustrative statistics gives you the direction about the data, but ultimately whether it is significant or not, that is being proved by inferential statistics. Now today's session we will be focusing entirely on illustrative statistics, that because you know today's session is visualization of data, so we will be speaking through graphs. So this till now it is clear. what we are going to do?
Yes, sir.
So there are different types of graphs. I will be doing one by one. But before talking about the graphs, I am telling you that in SPSS, when you are using graphs, basically the two most popular approach of using graphs is one is legacy dialogues and the other is chart builder. These two is the most popular and very easy to use. I will start my first session with legacy dialogues. Then after doing this legacy dialogues, we will have a 5 minutes tea break, and after the tea break, I will be using chart builder. So both approach helps you to generate graphs. We will try to look at how these two approach helps us to build graphs. Now, today I will start with legacy dialogues as I mentioned. So the first graph that we are going to draw using legacy dialogues will be graphs displaying distribution of scores. Now, when you are trying to find out distribution of data or score in this case, the most popular graph that we use is histogram in order to find out the distribution of scores. So this is the data set that I have shared with you. You just click this histogram data. Can you see my screen? Screen is visible?
Yes, sir. Yes, sir.
Yes, sir.
So first try to understand the scenario behind this data or the case study of this data set, and then we will do the graphs. It will help us to understand in a better perspective. Now, what does this case study talks about? This case study talks about, see the data set, the size of the data set is 20 and 10 male and 10 female, or we may say 10 girls, 10 boys and 10 girls are there. And 2-week period time is mentioned, week 1 and week 2. If you go to the variable view, all these things are already have been taught, I think. So if you see this, week 1 talks about week 1 time on homework, and similarly week 2 talks about week 2 time on homework. So what does this mean? This means that a teacher actually noted the number of minutes these 10 boys and 10 girls, say aged 9 years, spent on their homework over a 2-week time period. So these are recorded in minutes. What you see, 45, 51. So the first respondent or the first boy took to complete his homework in week 1, 45 minutes, and took 51 minutes to complete his homework in week 2. Like this, the data set is recorded for 20 respondents, 10 male, 10 female, and the recorded time is in minutes. Now, if you want to display the graph showing distribution of the scores, or here recorded in minutes, and if you want to understand whether your distribution is normal or not, whether your data set shows normality or not, you may apply histogram. So how to do that? Now go to graphs. You see graph board template chooser. Today I will not cover because it is not very popular. The two most popular is legacy dialogues and chart builder. That too I will cover at length. So let us start with legacy dialogues, because I have mentioned that I will start with legacy dialogues in the first session. So what graph we are going to choose in order to show the distribution of scores? Can anybody tell me which graph we should use? Histogram. So come to histogram, click it. This dialog box will open. Are you doing along with me?
Yes, sir.
Yes, sir.
Because you, all of you have the data sets that I am using.
Sir, more focus on the printed part of the screen is needed. Actually, the font size is too small. I mean, if this can be somehow done.
Since I'm using the share screen and I'm using the entire screen, so no option to enlarge it anymore.
Okay, sir.
You can't see the dialog box?
Sir, it is visible, sir.
Okay.
Full screen visible.
So now what we are going to do, suppose we are trying to understand the variable 1, that is week 1 time on homework. So put it under variable and click this display normal curve. Then it will automatically test whether week 1 shows normality or not. Now, if you click OK, see histogram is being given. What does it show? What we can infer from this diagram? In the Excel?
Negatively skewed.
No. More or less it is showing normal distribution. I will come. See the bell-shaped curve. The bell is more or less equal. And in the x-axis we are measuring week 1 time on homework, and in the y-axis we are measuring the time taken or the recorded time in minutes. And if you see the right hand side, mean, standard deviation, and n is given. N is the sample size. 20 students have their homework time has been recorded. What is the standard deviation? 32.619. That is the spread of scores among 20 students. What is the mean time they have taken? That is 102.15 minutes. So by looking at the histogram and the superimposed curve, that is the bell-shaped curve, we can evaluate the distribution of our scores. And if the bars of the histogram follow a similar pattern to this bell-shaped normal distribution that we have drawn, we can assume that the scores obtained come from a normally distributed population. Now, we can do it separately week 2 as well. How? Again, I'm showing. Again, if you go to graphs, go to legacy dialogues, click histogram. Now, you can check week 2, put it under variable, and if you click OK, see week 2 time on homework histogram is given. Now, what is the mean time? 99.15. What is the standard deviation? 30.937. 20 students have been recorded. Now, it is difficult for us to compare week 1 and week 2. Why? Because through legacy dialogues, only one graph at a time is being given. Now, if we want to compare two graphs, and if we want to set one beside one another, what we can do, again I'm closing this, we can go to analyze, we can go to descriptive statistics. Under analyze, under descriptive statistics, we can use this frequency table. Now we want to check both at a time. So I am bringing under variable box both this. Now if you click charts here, see histogram is given. So if I click histogram here and click this show normal curve on histogram, and if I click continue, and if I click OK, see two graphs given. Now we can compare between the two. What you can say from these two graphs? Can anybody infer?
Time is different.
Huh?
Mean time is different.
Mean time is different. So week 2 mean time is lesser than week 1 mean time.
Okay.
So we may say that the 20 students took less time to complete their homework in week 2. Now,
Yes.
since we can say that since they are in practice, so when they are coming from week 1 to week 2, they can improve their scores or improve their time. So not only that, if you check the standard deviation, the spread of scores in week 1 is lesser in week 2. It is more in week 1, it is less in week 2. So more or less, the students are performing or taking time average time to complete their home task. So this is clear?
Yes, sir.
Yes, sir.
So you can use in your research as well. Just double click this, and if you click copy, you can bring it in your Word file. Similarly, you can put this one as well. Now,
Sir,
yeah,
the frequency is 20, so the scale is 6y.
can't understand.
Frequency is 20, but when the graph is represented, so scale is 6y.
Scale is 6. Where
Yes,
you
sir.
got it?
Sir, in histogram,
Where you are getting?
x2. Sir, frequency side.
Yeah. The software is taking it as a 6-point scale. Okay. To count the frequency. If you check here, week 1 time on homework, x-axis measuring week 1 time on homework, and more or less it is ranging from 0 to around 200. This is measured in minutes. And in the y-axis you are measuring, what is you are measuring? Y-axis, what you are measuring?
Number of male or female.
Yeah, means the respondents. So if when you are measuring respondents, it is measured in a 6-point scale, means the 20% are fitted in a 6-point scale. Okay. Now
Okay, sir.
we can change this also. I will come later. We can change this axis if we use chart builder. In legacy dialogues, you cannot change whatever is the software gives. You have to take it. But if you use chart builder, you can change accordingly, according to your choice. Okay, that we will show later. Clear?
Okay, sir.
Now, in histogram, what data is shown there? What statistics is shown? Standard deviation, n is the sample size, and mean time. Do you remember or not?
Yes, sir. Yes, sir.
So basically, when you are using histogram, histogram uses measure of central tendency as mean. Now, if you want to use measure of central tendency as median, and if you want to use measure of, say, dispersion as, when you are using histogram, the measure of dispersion is standard deviation. If you want to change it, if you want to use, say, measure of dispersion as range, then you use box plot. I will compare between histogram and box plot. Let us first draw a box plot and then I will compare with histogram. So now with the same data, suppose I want to draw a box plot. So how I will go? Go to graphs, go to legacy dialogues. Here you see you have box plot. So click it. Now we have two variables, week 1 and week 2. So we will be using summaries of separate variables because we want to check box plot for separate variables. One for week 1 time, second for week 2 time. So I am choosing summaries of separate variables, and simple box plot will do. No need to cluster. Clustered we will do it at other times. So simple will help us to understand the box plot. So I am choosing simple box plot and I am using summaries of separate variables because I want to show the two variables, week 1 and week 2 separately. So click define. Now under define, which I want to see first, that is week 1 time on homework. So I put it under boxes represent. And now I want to check only week 1. Later I will check week 2. So I now click OK. See here the box plot is being given. Can you see the box plot?
Sir. Yes,
So
sir.
how and can we interpret this box plot? You have any idea? The distribution of scores previously was shown with the help of histogram. Now I am showing with the help of box plot. So how can we interpret this? What is this line? Can you anybody tell me this black line within the box?
It is a median, sir, Q2.
Very, very good. This is the median value. And this is the Q1. This is Q3. So this is the interquartile range. This colored box we call as interquartile range. That is the 50% of the data is concentrated here. So this Q1 we call 25th percentile. Q3 we call 75th percentile. So between 25th and 75th percentile, that is 50% of the data is concentrated here in this box. And this dark black is the median value. This line extended here, this line extended below, these are called whiskers, WHISKERs. This point shows the maximum value of the data set. This point shows the minimum value of the data set. Now, from the box plot, the beauty of the box plot, better than histogram, I will show you that box plot helps us to estimate if there is any outlier, if there is any extreme value. Histogram cannot detect extreme values or outliers, but box plot helps us to determine extreme values and outliers. What are outliers? Outliers are those scores that are more than 1.5 box length for this 25th or 75th percentile. Means it is 1/5 times more than this 25th percentile or 75th percentile. And extreme values are scores that are more than 3 box length. Means it is double. 1.5 is outliers. 3 times is extreme value. And extreme value are denoted as star and outliers are denoted as circle. Now, in this data set, you can see the box plot which has been given. There are no extreme values, there are no outliers. But at certain times, we can find this as well. And so, can you tell me that given histogram, given box plot, which one you should choose?
Box plot, sir.
Why?
It gives more detail about the data, how it is distributed.
Yes, correct. Because if there are outliers, if there are extreme values in your data set, when you do inferential statistics, it will give you misleading result. So from these box plot, if you can correct your data, if you can actually avoid those outliers or extreme values, then your result which inferential statistics will give meaningful results. And here also you can check that if your data set is normally distributed, then the box plot will be more or less symmetrical. And the median line, which is the black line here, will be more or less be in the center of the box. And the whiskers, which are extending at the top and the below, will be more or less of equal length. So from this box plot, it will help you to understand whether your data set is following normal distribution, and not only that, whether there is any extreme values or outliers in your data set. So this is clear.
Yes, sir. Yes, sir.
Now I am using this another data set which I have mentioned as box plot. You just click this data set, box plot data set. See this data set. This data set is an extension of the earlier one. There previously there were 20 respondents, 10 male and 10 female. Now there are 30 respondents, 15 male and 15 female. 10 I have added, and only I have taken week 1 time on homework of them. And from this data, anything new which you can see? Can you tell me?
Value, missing value.
Yes. In 23rd row, you see there is a missing value. Now, maybe I have entered wrongly. That's why it is showing missing value. Again, if I check the original script, I may put this recorded minutes. But suppose there is wrong in collecting the data. Suppose this 23rd male candidate, you fail to record his time taken for homework, then it is a true missing value. So box plot will help us to understand whether there is any missing value. In a large data set, it is very difficult to understand whether there is any missing value or not. It is a small data set, so that's why we can locate it. So in 2000, 3000, 1000 data set, it is really difficult to understand whether there is any missing value or extreme value or outliers are there or not. But let us try to do this. Go to graphs, legacy dialogues, go to box plot, simple, summaries of separate variables, define. Week 1, we are putting under boxes present. Now click OK. See here. Can you see this circle and star, which was not
Yeah.
previously shown in the box plot?
Yes, sir.
So what does this mean? What does this circle 28 means?
This is the outlier, sir.
It is an outlier. Very good. What does this star 26 means?
It is a missing value.
No, it is an extreme value.
That's
Star denotes extreme value, circle denotes outliers. So the 26th respondent shows extreme value, the 28th respondent shows as an outlier. So it helps you to actually reframe your data. Now if you analyze, if you do the inferential statistics on the basis of your 30 data set, your result will be meaningless, because 28 and 26 will actually help you to distort your analysis. So what we should do, we should remove this 26th respondent and 28th respondent from our data set, and we should do the analysis, because extreme values and outliers distort the analysis. Clear?
Sir, one thing, sir, why in some cases box is the rectangular, some cases in square?
I can't hear you properly. Just repeat once more.
Sir, in this box plot, you have box and whisker.
Yes.
The size of the box in some cases is the square, and some cases in the
Actually, this box plot is showing you the distribution of your scores or records or variables.
Sir, it also gives the any deviation.
Yes, of course, because if the box size is more, means the spread of scores is more. If the box size is less, then the spread of score is less. So here we are measuring the spread not with the help of standard deviation like histogram. We are measuring it with the help of range. This is called the interquartile range, Q1, Q3, and the dark side is the median value.
Sir, the median length is the more length in this case. Why it is more deviated value data?
Yes, of course.
Thank you, sir.
Okay.
Okay, sir.
So box plot is clear to you, extreme values, outliers, and what you should do with it, if there is any. Please give some response, otherwise I don't understand whether you are getting my point or not. Just unmute and talk with me, because I cannot see the message box now because I'm sharing the screen.
Sir, what's the difference between the extreme score and the outliers?
Yes? What is the difference between?
Extreme and outliers.
I've already mentioned that in case of outliers, it is 1.5 times more than the Q1 or Q3. That is the interquartile range. Q1 is this. If you see my screen, this is the Q1. This is the Q3. And this is the median value. So it is 28 is out of the whiskers. So it is outlier. It is 1.5 times more than Q1 or Q3. And 26 is the extreme value. It is 3 times more than Q1 or Q3. Clear?
Okay, sir. Thank you, sir.
So these should be removed from your data set. Otherwise, it will give you meaningless results when you do inferential statistics. How to detect? Through box plot. Here?
Yes, sir. Yes, sir.
Now, suppose I want to understand the difference between male and female, because we have a data set comprising of male and female, how they have scored in their homework, means how much time they have taken, whether male have taken more or female have taken more, what is their performance. If we want to check it with the help of graph, then what you can do is, I will show it. You want to check?
Yeah. Yes, sir. Yes, sir. You can show. You
So
can show.
let us go to the data set again. Go to graphs, go to legacy dialogs, go to box plot. Simple. Now we want to check male and female. So we have to use summary for groups of cases. Cases means here male and female. Click define. Week 1 comes under variable box. Under category axis, bring gender. That is male and female. And click OK. Now see. There is one missing value in male. That's why 14 respondents are there. And there are no missing values in female. That's why 15 respondents are there. And if you check the box plot, in the female itself, there is extreme values and outliers. In male, there is not. But if you check the box plot size, then you can say that the female have taken more minutes for their homework or have taken more time to do their homework than male. Now, since we are only measuring the time taken, we may say that female are more sincere and they have taken more time to do their homework than male. But whether it actually increases their score or marks or not, if we can gather data on the marks, then we will be able to draw a relationship that whether taking more time on homework will lead to better result or not in the exam. Clear?
Yes, sir. Okay.
So till now, you can understand?
Yes, sir.
Any doubt you may ask me, otherwise I will move forward. I will move forward.
Yes, sir. Yes, sir. Move, sir.
Now, my screen is visible.
Yes, sir.
Now let us check graphs for data, say with an independent design. There are 3 types of design. Graphs for data with an independent design, graphs for data with a repeated measured design, and graphs for data with a mixed design. Now, can anybody tell me what is independent, what is mixed, and what is repeated measure? Can anybody tell me?
Sir, explain little bit.
See here, independent design means the respondents are independent. Means you are trying to say understand the respondents. Here the respondents are male and female in our example, and there is a grouping variable. A grouping variable is the gender. There is different. There are two groups. One is male and the other is female. And if you want to understand the mean time spent on homework between males and females. So this is an independent design because the 10 males and 10 females are independent of each other. In case of repeated measure design calls that same respondents are repeated for an experiment. Suppose in the morning time, it has been tested again in the afternoon time with the same respondents, it has been tested. So it is called a repeated measure design. They are not independent. The same respondents are repeated the experiment. And in mixed design, it is a combination of independent and repeated measure. So I will show these graphs with examples and data sets. It will help you to understand better than words, because I have already mentioned that graphs actually speaks 1000 words. So just for the sake of independent design, say we are taking the same example, we are producing graphs using a grouping variable. Here, say our grouping variable is gender, male and female, or boys and girls. And the same example we are taking, that how many minutes they have took to complete their homework, say in week 1. So now I want to use, say, so this was our example, this data set, 20 male, 10 male and 10 female, and week 1 and week 2 homework time. This was our case.
Yes, sir. Yes, sir.
So independent design means we want to check separately the male and female. So what we will do, if we want to draw a graph on independent design, then we cannot use box plot or histogram. We have to use bar chart. So now go to graphs, go to legacy dialogs, go to bar. Here we will be using simple bar chart. It will suffice for us. And since we are trying to find out male and female, so summaries for groups of cases we need to tick. You click define, and here what we need to do is we will be taking week 1 mean time first. So just click other statistics here and bring week time 1 on homework under variable box. And we want to check the gender, that is the category wise. So male and female, that is gender, should brought under category axis. You can follow me.
Yes, sir.
Those who are doing along with me can follow me.
Yes, sir. We can follow you.
Okay. Now click OK. See here. What we can infer? What we can infer?
Takes more time.
Female took
More time.
or spent higher mean time on homework than the males. And it is very clear from this bar chart. But only by seeing the numbers, you cannot tell. Only by checking these numbers, you cannot tell. It's clear, I think.
Yes, sir. Yes, sir.
Now, in independent design, we can use not only simple bar chart, we can use clustered bar chart as well. So I'm going to clustered bar chart now. This is a case of graphs with independent design, which I was showing through simple bar chart. Now I will be using clustered bar chart. Now, what is the scenario of this data set here? Can anybody tell me by looking at this data set? Can you infer any meaning from this data set?
No, sir. Machine error and experienced person. Quality of machine and experienced person, how much they do the error.
Yes. So actually, say suppose a new manager of a factory, and he is keen to reduce the number of errors made at his factory. And he had divided the staff into two. One is those who are novice or those who are new, and one those who are experienced. So here we have 24 respondents, 12 are novices and 12 is experienced. And also noted here that there are two types of machine, old machine and new machine. So some old machines are being given to the novice staff and some new machines are given to the novice staff. Similarly, some old machines are given to the experienced staff and some new machines are given to the experienced staff, and now errors were recorded. Now you want to, what you want to do? You want to check or display the errors on the basis of staff as well as on the basis of machine. So here, since we have more than we have two variables, the one is machine and the other is staff. So, and here there is a grouping variable as well. So it is an independent design. We cannot use simple bar chart anymore. We have to use clustered bar chart. So go to graphs, go to legacy dialogs, go to bar, select this clustered bar chart. Have you selected? Are you following me?
Sir.
Yes, sir.
So we want to use this novice and experienced staff while generating the graph. So we will be using summaries for groups of cases because our grouping variable is novice and experienced. So now click define. Now similarly, what we will do, we will, in other studies, that is the meantime, we will bring the error under variable box, and in the category axis we will be bringing staff, that is experienced and novice, and you can use these define clusters by machine. So three variables, we have brought staff under category axis, machine under define clusters by, and under the variable box, that is the mean error time. And now if you click OK, see, nice illustrative graph has been given. Now how to interpret this? Can anyone interpret?
More experience with new machine, but experienced person are experts are on new machine. No, peace. old machine. Novice can be more handle, less error in the old machine. Like this.
See, here we have generated the chart or a graph which speaks about two groups. One is novice and the other is experienced. And not only that, this novice and experienced staffs are handling two types of machines, old machines and new machines. And here in the y-axis, we are measuring the error, mean error. So if you check for the novice staff, whether they are using old machine or new machine, the error is more or less same. But for the experienced staff, when they are using old machine, their error is much less. And when they are using new machines, their error is much more. Not only that, from this graph, we will be able to allocate the machines to the staff. Why? Because from this graph, it tells us that we should give old machines to the experienced staff and new machines to the novices. Why? Because if you compare the new machines among novice and experienced, the errors of experience are much more than novice. So from the graph only, the manager can decide which machines to be given to whom. Clear?
Okay. Sir, we can reverse in staff we place the machine and here the language staff. We can reverse the data.
How can you reverse your data? This data is the recorded, is the
Right.
original data which you have taken. Now, how can
In place of staff we say place the machine, and in the bar chart we say the staff. How much is staff? Like this.
see? Basically, you can. This is a horizontal chart. You can do it in vertical manner, but ultimately the interpretation is same. The interpretation of the graph is same. Whatever layout you use,
Okay.
whether you use chart builder or legacy dialog, whatever you do, ultimately the meaning of the graph which is generated is same.
Okay, sir. Thank
The pattern is emerging. We can see that within the novice group, there is hardly any difference in the number of errors because old and new machines are more or less showing the same number of errors recorded. And for the experienced staff, we see that more errors are made when they are handling new machines than old machines. So as a manager, I should take a decision that when I will be allocating machines to the staffs, I will be giving new machines to the novice and old machines to the experienced. This is the managerial decision I need to take. These statistical things, what we do in our research, these are all meant for taking decisions, managerial decisions. Clear?
you. Okay, sir.
So, other participants, are you with me? I can't hear your voice. You are sleeping or not, I don't know. Whether you are interested or not, that I also don't know. You are not communicating with me. If you have any doubt, you may ask me. And if you have no doubt, then also you can use the chat box and tell that I have no doubt. Just in order to make myself understand that whether you are with me or not. All the participants, I need some feedback in the message box. So no doubt till now, so far so good. Thank you. Thank you for your response. So let us continue. You can see I have written that graphs for data with an independent design, which I have shown you just now. Now we are going for graphs for data with a repeated measure design. And then we will follow up with a mixed design. So let us now go for a repeated measure design graph. So go to my data set, just click the error bar graph, error bar data. I think all of you have these data sets with you. It has been shared with you.
Yes,
Yes,
sir,
sir.
we have.
Have you opened this data set?
Yes, sir.
So let us discuss the case study here. Actually, see here 12 respondents are here, and their time in minutes is recorded in wet conditions and in dry conditions. Actually, they are runners. So a team coach, he wanted to know whether the performance of these runners affect due to weather conditions or not. And this coach has told these 12 runners that you run a 5-kilometer run, and I will record your completion time for this 5-kilometer run. And 12 runners, they run 5 kilometer during wet conditions and during dry conditions. And the times were recorded to the nearest minute. And this is the data set which you can see. So now we will try to understand through this error bar graph that whether in which conditions the performance is better for the runners. So go to graphs, go to legacy dialogs, go to error bar, and simple will do. Here we will be selecting summaries of separate variables because we have two variables. One is the wet condition, the other is dry condition. Click define. And under error bars, both these variables should be brought. And you just click OK. See here, the graph has been generated. So you can see from this graph that on the x-axis we are measuring the two variables, that is a 5-kilometer run recorded in minutes on wet conditions and dry conditions. And can you see a square or a circle rather in the middle of these whiskers?
Yes, sir.
What does this mean? This is the mean time taken. This is the mean time taken by the respondents. So can you see the y-axis here? 95 confidence interval is being given. So what does this mean? This means that the two whiskers we can see here from the box plot, we have understood the whiskers. So the two whiskers that accompany the mean, that is the circle here, are the 95% confidence intervals. And by looking at the graph, we can see that in the wet weather conditions, the runners had a slower mean running time with a wider confidence interval than in the dry conditions. So in the wet conditions, the runner automatically, it is hazardous in the wet conditions to run. So that's why the mean running time taken is more than in dry conditions. So this is clear.
Yes, sir.
The length of the whisker plus also indicate the deviation.
Yes, of course.
If the length is more deviation.
More spread.
More spread, and it's also it gives the error of the standard error. It indicates standard error or standard deviation.
Here basically when you are using the error bar graph,
Hmm.
we have used the confidence interval for mean. You can use another option as well. I'm showing you. Go to graphs, go to legacy dialogs, go to error bar. Here, can you see
Yes, sir.
confidence interval for mean, standard error of mean, and standard deviation? So you can choose any of the three, but we have used confidence interval for mean. You may use standard deviation or standard error of mean as well. Clear?
Okay, sir.
So can you tell me what is the difference between independent design and repeated measured design then? Two examples I have used and I have shown how to generate graphs. What is the basic difference? Can anyone tell me? Hmm? You are with me?
Yes, sir.
Yes, sir.
So can you tell me what is the difference between independent design and repeated measure design?
Repeated measure, same person, different times.
Correct. When you are using repeated measure, you are using the same respondents, the same persons in your research at different point of time. And there is no grouping variable. But in case of independent design, there is a grouping variable. Here, maybe male, female. And same respondents are not being recorded. They are independent of each other. That is the basic difference.
Like a pair t-test. Data, pair t-test like data.
Actually, pair t-test is an example of repeated measure design, but I will not talk about pair t-test because
Okay, sir. Data looks like that, sir.
yeah, but when you are using inferential statistics, I have shown you there are three types of statistics. One is descriptive, second is illustrative, third is inferential. When you are using inferential statistics, you will be using pair t-test for repeated measure design.
Okay.
I will not talk about that because today's my lecture will be focused on only illustrative statistics.
Okay, okay, sir.
Okay. So till now, if you have any doubt, you may ask me, or otherwise I will go for a mixed design now. Mixed design means it is a combination of both independent and repeated measure design. So click this line graph. Have you opened this data set?
Yes, sir.
See here in the mixed design, we will have both independent variable or grouping variable and new repeated measure variable. See here the grouping variable is two type of staffs. One is novice staff, the other is experienced staff. So there are 6 novice staff and 6 experienced staff. Total 12 staff is there. And why it is a repeated measure variable? Because that same 12 staff, their errors in week 1, week 2, and week 3 is being recorded. So it is a mixed design case where both repeated measure as well as a grouping variable or independent design is there. So in this type of data set, you have to use line graph. Clear?
Yes, sir. Yes, sir.
So we will generate the graph now. Do you agree?
Yes, sir.
So go to graphs, go to legacy dialogs, come under line graph. Under line, tell me which graph we should use, simple, multiple or drop line.
Multiple,
Why? What is the logic?
because the different data.
Yes, three, this is a repeated measure case and 3 variables are there. So if there is only one variable, you can use simple line chart. If there is more than one variable, you have to use multiple charts. Clear?
Yes, sir.
And we have separate variables here, week 1, week 2, week 3. So we will be using summaries of separate variables. Click define. Now what we will do? Workers should be sent to the
category access.
So let us bring this week 1, week 2 and week 3 under line and under mean values will do for us, no issue. So you can see here, we want to, on the basis of workers, we want to understand the errors recorded during 3-week period. So we have brought week 1, week 2, week 3 under line represents. Now click OK. Here, you can see that during week 1, the errors were more, during week 2, it was less, and during week 3, it was far less. But this is the average mean time taken for all the stuff. Now, we want to understand what are the performance of novice as well as experienced staff. So we have to generate a alternative graph. How we can do that? How we can choose? So go to graphs, go to legacy dialogs, go to line. It will be a multiple line chart and summaries of separate variables. Define. Bring week 1, week 2 and week 3 under line represent. Under category axis, bring workers. Now you use OK, then you will be able to generate. See here. How do you interpret? This is the exact graph which displays the entire data set. Now, how do you interpret? Can anybody do the interpretation?
Sir, in novice to when novice to experienced person, mean time is increases. In case of week 1, week 2, week 3, in week 1, it is the increases. Now, when novice to experience, week mean time increases. This one in day 2, it is the decreases. In day 3, it is more decreases. So, if the experienced, it get less time.
Yes. So
Worker get
we may say that from the graph, it does appear that there is a pattern in the number of errors made by the workers over a 3-week period. So in week 1, what we can see, the experienced operators were making more errors than the novices. So this trend is not evident in week 2. If you check week 2, both the workers are making a similar number of errors. But if you check week 3, the trend has been reversed. Now the experienced workers were making fewer errors than the novice counterparts. But if you check the third week compared to the week 1 and week 2, you may say that all the workers, whether novice or experienced, were making fewer errors in week 3 compared to week 1 and week 2. because if you see the line, see here, novice errors and here experienced errors in week 1. So in week 1, novice errors were less, experienced errors were more. In week 2, more or less similar number of errors are made by novice and experienced. But in week 3, check that the experienced workers are committing lesser or fewer errors than novices in week 3.
It can be visualized by bar chart, 3-bar chart for novice, week 1, week 2, week 3.
You can do, but generally what happens is, in case of multiple variables where there is grouping variable as well as there is repeated measure variable or repeated measure design, line is easier to interpret than bar.
In generally, we can do in novice 3-bar and in experience 3-bar, 1 week, 2 week, 3 week, and we compare.
It will be difficult to compare then, because if you generate 6 bar graphs, it will be difficult to compare in a one graph. Here, only in a one graph you can compare.
Yes, sir, it is.
That is the beauty of this. When which graph you use, that is very important.
Okay, sir.
So this is clear. The interpretation is clear to everybody. Others, can you unmute and talk?
Yes, sir.
Yes, sir, it is clear.
Yes, sir. It's clear.
Okay. Thank you. So one more left, that is graphs My screen is visible. Can you see my writing?
Yes, sir.
Graphs illustrating say frequency counts. You understand that frequency counts means nominal or ordinal data. Whatever graphs we have generated till now are all for continuous data, that is interval or ratio scale data. But suppose if you have nominal data, then you have to use frequency counts for generating the graph. And which graph is used for generating frequency counts or illustrating nominal data is the pie chart. So click this pie chart data set. Can you see this data set?
Yes, sir.
Go to variable view. Here, see, we are actually,
Right.
there are 5 types of vehicle. 1 we have denoted car, 2 we have denoted bus, 3 we have denoted lorry, 4 we have denoted van, and 5 others. Basically, the story behind this data set is a group of school children, they were asked to conduct a traffic survey in their village. And they recorded this, the first 20 types of vehicle that passed by their school. You can see that there are 20 types of vehicle here recorded here. And the categories we have recorded as given by them is 5 types: car, bus, lorry, van, and others. And you can see the records. Now here you can see this is the nominal data, because only you are getting types of vehicle recorded. So there is no interval or ratio scale data, no measurement. How you generate this graph? Here for nominal data, we use generally which graph? Pie. So come to this pie graph. Dialog box is seen. It can be seen, this dialog box.
Sir, yes, sir.
We have different types of vehicles. That's why summary for groups of cases we will record. There are no variables. So click define. And here, what we need to do, we want to measure number of vehicles. So n number of cases is okay. We want to measure that. And vehicle should be brought under define slices by, because pie actually shows slices. So vehicle is brought under define slices by. This will ensure that each type of vehicle is grouped, and the total counts will also appear. And we are interested in the frequency counts of each vehicle passing through the villages. So n number of cases is okay here. Now, if you click OK, see, chart is given. How you can interpret? How you can interpret?
There are more cars on the road.
Yeah, there are more cars on the roads, followed by vans and lorry, in that order, from the size of the slice. So the pie chart actually shows the majority of vehicles that are passing by the village. From the pie chart, we can easily interpret that there were more number of cars, followed by vans and lorries. And it will be better for us if we can show the values or percentage within this slice. How can we do that? So for doing that, just click this graph. A chart editor will open. Have you got this chart editor with you?
Yes, sir.
So what we need to do now? We need to change this. So we click on the one, any car, bus, lorry, van, whatever, any one you click, you will get this box. Now what we need to do? See, if you sort by level, it highlights that the car is maximum than others. Again, if you click value, more or less same. So use custom only. Now now come to elements and you just click the show data labels. And Now, if I want to bring vehicle here also and percentage, now if you click apply, see here, can you see 45% of the vehicles run through the villages are cart. Similarly, you can put all these slices as well. Getting my point?
Yes, sir.
Yes, sir.
So this is much better interpretable than the earlier one. Why? Because percentage is also being shown. If you use that data label, automatically for each slice, the percentage of that vehicle running through the village will be shown. So it is much easier to interpret. So this is clear or not?
Clear, sir.
So legacy dialogues is over. Now we should understand the chart builder now. There is two approach I have mentioned. One is legacy dialogues, the other is chart builder. So are you interested in understanding the graphs with the help of chart builder?
Yes, sir. Yes, sir.
Yes, sir.
Yes, sir.
So just use the message box and tell me whether you are interested in understanding the chart builder approach. I want some message. Already I have received 2-3 messages. I need some more. So I will show you two new graph: histogram, pie chart, box plot, line graph, error bar graph. All these we have done already. I will show you one extension of his say histogram, that is, we call it is a population pyramid. It is very very popular. And another thing I will show you, if time permits, I will show you a panel graph and I will finish today's session. So let me share my screen first. So can you see my screen?
Yes, sir.
So let us use this work program datasheet. Work program. See, basically initially we were using small data sets. Now legacy dialogues can handle small data sets. Legacy dialogues cannot handle large data sets. If you want to use large data sets, you have to use chart builder. Now, if you see the data set size, just check. What is the size of the data set?
1000.
1000. So this is a real data set. I will show you how to use real data set for building graphs with the help of chart builder. Now here, what I will try to develop is what we call it as We call it as population pyramid. Now, this population pyramid is used for categorical data, that is nominal or ordinal data. And another thing, panel graph, I will show you, that is used for continuous data. Continuous data means interval or ratio scale data. So let us start with this nominal or ordinal data first, that is the population pyramid. So here you see there are 8 variables. One is age of the respondents, their marital status, whether they are married or unmarried. INC-BEF means income before joining the program, the work program. INC after means income after joining the work program. ED means that what is their education level, gender, where they reside, and whether they have attended the program or not with 0 and 1. 0 means they have not attended the program and 1 means they have attended and completed the program. So this is the data set. Now, what do you want to do? We want to build a graph which is called the population pyramid, and this type of graph is generally used for both continuous scale data and nominal scale data. You can use it, and basically in order to understand the relationship between the discrete variables, this graph is much popular, this population pyramid. And if you check the educational level here, if you go to variable view and check the education level, see here what is the education level.
Four levels, sir.
So 4 levels. One is did not complete high school, second is high school degree, third is some college degree, and fourth is post undergraduate degree. Now we need to draw a population pyramid. So now generally we try to pose certain questions from the data set, and we want to understand the answers from these graphs. So I will pose questions later. First, let us draw the graph. So go to graph, go to chart builder. Then you have open this chart builder. See here, this gallery should be selected. And in gallery, we are clicking histogram. When you have clicked histogram under gallery, you see there are 4 options. One is simple histogram, stacked histogram, frequency polygon, and population pyramid. So we want this population pyramid. So I am double clicking it, automatically it will come here. Now, when you have selected the population pyramid, now you have to use the variables. Now there are 2 types of variable here. Can you see split variable and distribution variable? So let us bring marital status under split variable. So I am bringing marital status under say split variable, and let us bring level of education under distribution variable. So here is the level of education, I am bringing it under distribution variable. So we want to check the marital status as well as the level of education on the respondents, that what is the relationship between these 2 discrete variables, that is marital status and level of education. Now, so this is done. I'm clicking OK. See here, what you can interpret? it is not very clear. Can you see that post undergraduate degree, there are no candidates? Only some college, high school degree and did not complete high school. You can get married and unmarried. Can you see the graph?
Yes, sir.
There is any candidate on this category, post undergraduate degree?
No,
No.
sir.
So we cannot use this graph. Means we cannot use this graph in our analysis. What we need to do? We have to modify it. So how we can modify? Only with the help of chart builder. I was talking previously that only with the help of chart builder you can modify. In case of legacy dialogues, you don't have any chance to modify the graph. So what you do is double click and chart editor will come. Now, when you have used this chart editor, now you can click to any number. Say I'm clicking 250 here. So when you have clicked 250, now it is highlighted. Can you see all the numbers are highlighted?
Yes, sir.
Now, what we need to do? Go to elements, properties. Yeah, under edit, you see this properties icon. Click this properties. Can you see the properties dialog box now?
Yes, sir.
Yes, sir.
Click the scale tab. We have to rescale it. Otherwise, the graph is not meaningful for us. So click the scale tab. See, in the range panel, this is the range panel. Change the minimum from 50 to 0 because we want to start from origin, 0. Click apply. Now, say, click any of these icon in the unmarried category. Say, suppose I'm clicking this one. Any of these 3. See, again, the dialog box appears. Now, go to fill and border. When you have click this click and border, fill and border tab, you get this color panel. Can you see this color panel?
Yes, sir.
Yes, sir.
Use this white one. Click apply. Now, again, click any bar in this, say, suppose this married category. Unmarried we have done. Now we are clicking married. So in the properties window, with this fill and border tab highlighted, click this one. Under pattern is not showing. Let us use later. We will use first. We get this category box here because we don't need a post undergraduate degree. So what we should do, variable marital status, go to level of education. Under level of education, we don't need this post undergraduate degree anymore. So we click cross. Click apply. Now see, it has already shown. Now it's okay now. Now if you click, say, suppose we are clicking this, and okay, already we have done this. Now go to options, view elements, show data levels. So if you go to show data levels and automatically you see this data levels is there. So just close it. So now can you see this graph?
Yes, sir.
It is much more meaningful or not?
Yes, sir.
So now if I say, after this graph we have generated, if I pose certain questions, would you be able to give answer? Suppose I'm posing one question. Which category of education shows the largest difference between married and unmarried individuals? Can you tell me from this graph?
In college level.
Which, again I am posing the question, which category of education shows the largest difference between married and unmarried individual?
Sir, college level.
Why?
Sir, here the difference is 108 and 85.
So 23, that is the maximum. Correct, you are. Now suppose again I am posing another question. What does the graph tell us about say possible relationship between the marital status and the level of education? What does this graph tells us about the relationship between marital status and level of education?
Unmarried have the highest education.
Hmm?
The
Sir,
unmarried,
please repeat the question.
unmarried people
The
have
question
the
is,
highest education.
by seeing the graph, if you are asked that what does this graph tells us about this possible relationship between, see, the marital status and the level of education? What is the possible relationship? What you will say? See, there is hardly any difference between the marital status and level of education. From the graph, you hardly can say that whether there is any difference or not. But this is only a direction that there is little relationship. But if you apply a inferential statistics here, that is between marital status and level of education, you will be able to tell it significantly, whether it is significant difference or no significant difference. What inferential statistics we can use here to find out the relationship between two nominal data? One is marital status and the level of education. Are you aware what statistics we use? Have you heard the term chi-square test?
Yes, sir.
So chi-square test is used to understand the relationship between two nominal variable. Here we have two nominal variable, marital status and level of education. If the graph, if you are not sure about the relationship with the help of a graph, then you apply inferential statistics in terms of chi-square. And then with the help of chi-square, you will be able to tell exactly whether there is any significant relationship or not between marital status and level of education. From the graph here, we can find that hardly there is a relationship between marital status and level of education, because more or less it is same. married or unmarried, the level of education is more or less same. More so in case of did not complete high school and high school degree. So this is how we generate the population pyramid, and we can manipulate it in order to make the graph meaningful. This is clear to you?
Yes, sir.
Yes, sir.
Next one.
So do you want to understand the panel graph, or it will be too much for you? Otherwise, I will leave.
Too much for you, me, sir. Sir, you can, sir, explain only the how can we put the bar, error bar on the bar chart.
Can't understand your point.
Sir, in generally we prepare the bar chart and in the top we put the error bar. So how can we put in SPSS error bar in bar diagram, bar chart?
Means what do you want to do? You want to
First error bar, first bar chart and then error bar. Error.
I have shown you how to create a bar chart. I have shown you how to create an error bar.
But simultaneously, sir, in bar chart, in any option.
That will be your homework.
In SPSS, that is the option.
Yes, of course.
Okay.
Of course, there is option.
Okay.
I have shown you two separately.
But simultaneously, you can
do.
Okay.
But with a different data set.
Different. You have the data set.
Now I don't have, because I was not planned to do that one.
Okay. Sir.
That's why I have not shared those data set. I have not now, but you can do it. No issue.
Okay, sir. Thank you.
Okay. That is possible. What you are talking, that within the bar chart, error bar,
Yeah, sir.
can be transposed.
Okay, sir. This one.
That
Okay.
can be done.
Okay, sir.